Welcome all. Today we are continuing with the playlist. Here the problem number 3. Best time to buy and sell stock 2. For a better understanding of this problem, I would recommend you to visit the previous problem in the playlist, that is problem number 2, best time to buy and sell stock. So what is different here is that you are given an integer array, prices, and what is different from the previous problem is that you are also allowed to have multiple transactions. So I will explain what does it mean. If this is the integer array 7 1 5 3 6 4, where each element represents the stock value on that particular day, and you also has a freedom to buy or sell on any day, and one condition is that you will be allowed to hold one stock at a time. I mean, you are not allowed to hold multiple stocks on the same day. So with that condition, you can go on and do multiple transactions, and you should get maximum profit, and should return the maximum profit you are going to get. How we are going to do? For example, I can give an answer to this particular example, then you will understand what I mean by multiple transaction. If I am going to buy on day 2 where the value was 1, and sell it on day 3 where the value is 5, here in this transaction I have made a profit of 4, and again I can purchase it on day 4 where the value is 3, and on day 5 when the value increased to 6 I sold it. So here I made a profit of 3. Like that I have made a total profit of 7. I have to find the scenarios where I can make a possible profit, and I just need to add all this profit and return the maximum profit I could obtain from this particular information. That's what I want to provide. And how we can do? One thing is by brute force. I'm not going to explain, I will explain the brute force, but I am not going to code the brute force, because that is a bit irrelevant. You will understand why it is. So first of all I try to motivate you regarding the time complexity where brute force is going to bring. For a given day, let the day would be day M. On a given day, you can have the option of sell or buy. You can sell it on any other day, on mth day, or subject to you already holding that stock, or any other m plus x day, or you can buy on that day, or you can choose to buy on any other day also. Once you did this transaction, this will also provide two options of sell or buy. Buy will also provide based on which day you want to do. So each day provides two options. So if you are going to calculate in a brute force fashion, the time complexity that is going to bring would be 2 to the power n, where the n will be the number of elements in that particular array. So that's a huge time complexity. So we need a better solution to solve it. And how we can solve it? So one simple thing to visualize is that the best way to make profit is to sell it when the stock price is high, and the best way to buy the stocks is when the stock price is less. So if I have already have some information, something like this, if suppose this is going to be the stock fluctuation, if I know this beforehand, I would be buying on this instance, and I'm going to sell in this particular point, and again I'm going to buy it here, and I'm again going to sell at this point, and I'm again going to buy here, and I'm again going to sell here, I'm again going to buy here, and again going to sell at this point. If I had this information before, I can make accumulated profit, like on each instance I know what is going to happen. Similarly, our problem also demands the same. It needs to return the maximum profit that could be obtained from this particular information. That is nothing but the price difference when you sold it here and when you bought it here. This should be added with this price difference and this price difference and this price difference. So it is very similar. You just have to traverse through the array and find out the valleys or peaks of the stock fluctuations, and you have to take this difference and accumulate on a particular variable, and you have to return that. That is the simple logic, and that will be the answer. Here also you can see 7 is a peak, then 1 it goes down, then there is 5. So this is the best thing. Buy it, sell it on 5 point and buy it on 1. Then again 3 goes down. 6 I have seen a peak again. Then I would have bought it on 3 and I would have sold it on 6. Then it can again go down, and I am not seeing any more option to buy. So the answer would be 5 minus 1 plus 6 minus 3. That would be 4 plus 3, 7. That would be the answer, maximum profit you could get from this particular example. So let's try to code it. So we can keep this example as it is, and class solution, and the method inside the class maximum profit, and arguments you can write by yourself, which is prices. This is nothing but a list of integers, and I am supposed to return another integer. I'm going to start with variable which I need to return, that is profit, which is 0 right now, and I'm going to traverse. I also need one more information, the length of the prices. I'm also going to write it here, length of prices. Let's traverse for I in range of for I in range of 1, and it will go up to n. Then prices, one thing is that I have to check whether it is a peak or value. If prices of I is greater than prices of I minus 1, this indicates that there is a peak I am going to see. If that is the condition, then just add it to the profit. Profit plus equals prices of I minus price of I minus 1. This will accumulate all the profit, and at the end I just need to return the profit. So what is the time complexity here? The time complexity is pretty much simple. It is traversing only one time. So the time complexity is order of n, and space complexity, we are not using any additional space, so space complexity would be order of 1. With that, I have explained the problem statement and with the examples also, and I have coded the better solution. So with that, this problem is done. So thanks for your attention. Thank you.